Okay, number 49, quotient rule. But again, remember, if you get a number, an answer that's 0 or negative, you can't count that because you don't have that with the natural log. You can't take the log of 0 or a negative number. Okay, so quotient rule. Low, D high is 1. Minus high, which is x. D low is 1 over x. So those are going to cancel. Draw the line and square below. Okay. The x's cancel, so my first derivative is the natural log of x minus 1 all over the natural log of x squared. When will the denominator equal 0? Never. When will the numerator equal 0? Add 1 to both sides. Exponentiate both sides. The e and the ln undo each other and you get x equals e to the first, or just e. So that's your only critical point. All right, so we have a critical point at E, and now we're going to plug that into the second derivative. Although, again, I think it would probably be easier for this problem. I don't know that I would do a second derivative test because the second derivative on this is kind of not pleasant. So I would rather do a first derivative test, which is what I'm going to do because I can. I'm going to break the rules.
Cool.
Okay, so I'm sorry, but I'm refusing to do the second derivative test on this one because the first derivative test is just easier. So, plugging in a number to the right of e, if this is e to the first, I'll plug in maybe an e squared. Okay, well that means if the bottom, by the way, is squared, so that's always positive. If I plug in e squared right here, the natural log and the e undo each other, and you just get 2 minus 1, which is 1. That's positive. In here, between 0 and e to the first, I could plug in e to the 1/2. I could plug in e to the negative 5, honestly. So whatever you want to do. So if I plug in either of those, if I plug in e to the 1/2, and this becomes a 1/2 right here, the natural log and the e still undo each other, and it's 1/2 minus 1, which is negative. I just think that was way quicker than trying to do the second derivative of this. So, critical point at e to the first derivative changed from negative to positive. That makes this a min. Min at x equals e. And I'm not doing the second derivative test because it's dumb for this one.